We said that IP addresses are in this format. For example, 2.2.2.2 or 4.5.6.7 are two examples of IPv4 addresses. But you might ask that, for example, in the previous lectures, we said that computer only understands 0 and 1, and 0 and 1 are a transistor which might be on or off. By convention we have made them 0 and 1, so computer could only understand these two numbers. How is it that we have these numbers in the decimal format? These kind of representations are only for us as human to better understand different numbers, because for us as human, understanding binary numbers is hard. In computers and memory, data are usually represented in 8 bits or saved in 8 bits, which we call a 1 byte. So a byte is a combination of 8, 0 or 1. Now if we look at the details of data, we could see that all the numbers are actually in the zeros and ones. For example, 2.2.2 is represented using these 4 bytes or 32 bits. So 000000010 is equivalent to 2 in decimal. Also 000000100 is equivalent to 4, and as you see, these other bytes are equivalent to 5, 6 and 7. So with this in mind, we could see that the lowest IP address possible that we could create is 32-bit of 0, as you see in here, and the biggest IP address is equal to 32-bit 1, which is in here. These 32 bits, 0 in binary is equal to 0.0.0.0, and these 32 bits in 1 is equivalent to 255.255.255.255 in the decimal representation. So we could say that IP addresses have been created or expressed using 4 bytes or 32 bits, and because each byte is equal to 8 bits, and we said that each bit has only 2 states, 0 or 1, so we could say that 2 to the power of 8, because it is equal to 256, so for each byte, for each digit of the decimal representation, we have 256 possible value, and therefore we could say that 256 times 256 times 256 times 256 for all 4 bytes, or in other ways 2 to the power of 32, which is equal to more than 4 billion, is all the IPv4 addresses or all the unique IPv4 addresses that we could create. At first, this amount of different IP addresses was enough, but then because we were creating more electronic devices every day and the growing rate was so high, we were somehow running out of IPv4 addresses. So even though the limitation of creating different addresses in a single device was overcome by the concept of port number, but we had this limitation for all the devices in the world. That's why we needed to create another concept, the concept of private IP addresses and public IP addresses. So 3 ranges of IP addresses were defined and were introduced as the private IP address, which are as following: 10.0.0.0 to 10.255.255.255 is the first range of all the IP private IP addresses, and so is these other 2 ranges. But how this concept solved the limitation of IPv4 addresses, we want to clarify this by making you an example.